Welcome to the Photonics session. This is the program information session for our Photonics program. Recordings of all sessions will also be available online after the event. So we are recording this session and you will be able to view it again after the event. The next slide that I wanted to talk about is just the fall term, because I'm sure that many of you have questions about what Niagara College is planning for the fall term, given the conditions of the COVID pandemic. So as Niagara College, what we're doing is we are closely monitoring current and projected public health measures, the vaccination rates, and other factors. And what we are seeing is we are planning for a significant increase in on-campus learning, and that's what we're anticipating for fall of 2021. At the same time, the health and safety of our students, staff, and faculty remain a top priority, and any courses and programs that return to campus will comply with all public health measures and directives. We will be providing updates regularly as information becomes available, and the delivery status for all programs will be posted in May. The most up-to-date and accurate source for information regarding our college operations and program delivery and information is on the Niagara College website, niagaracollege.ca/COVID-19. So please keep an eye on that, and you can see how Niagara College is planning for its operations for the fall term. And now I will turn it over to Alex, and Alex will be taking you through some information to give you more of an insight into the Photonics program at Niagara College.
Thanks, Dorita. So I've been involved with Photonics, as Mark mentioned, since the beginning, and I'm quite excited because this is actually our 20th anniversary for Photonics. And I was actually just talking about how the program has evolved constantly over those last 20 years to make the program as valuable to our graduates and to the industry that we possibly can. Currently in the Photonics program, we have two offerings. So we have a 2-year Photonics Engineering Technology program, and a 2-year Photonics Engineering Technician program, and a 3-year Photonics Engineering Technology program. The lovely thing about the way we have Photonics set up is the 2 years and the 3 years are entirely common, with the exception of 2 math courses. So my recommendation to most students is sign up for the 3-year program, because if you sign up for the 3-year program and you go through the first 2 years and you realize after 2 years, oh my goodness, I've got this company here is offering me a job, and you know what, I'm a little low on cash, and it's not a problem. You can put in and change your program from the 3-year program to the 2-year program and graduate. And the nice thing is, if you decide you want to come back and finish that 3rd-year program, the third year of the program, and do the technology program, you still can. So you're not out anything by transferring back and forth between those 2 programs. So we like to make the program as flexible as we can for our students. Those 2 math courses that I was talking about that make the difference are 2 calculus courses. So I've even had situations where students go through and they're really good on the hands-on aspect of it, maybe have a little bit more trouble with the math, and so they'll graduate after 2 years as a technician. Or like I said, they want to get that extra design element, actually going in and designing products and integrating the optical systems, which is what we do in the 3rd year the 3rd year of the 3-year program. The other big thing that we do in the last year of the 3-year program is we do a lot of what we call capstone programming, where it's actually a research project, and in some cases we'll even partner with industry to work on a product for industry. This year, and if we'd like to go to the next slide, you can actually see in the top right-hand corner the Capstone project that our students worked on this year. And of course, things have been a little bit more difficult with, some students have, of course, been doing some stuff on campus, but normally for our Capstone project in the 3rd year, the students are living on campus. And I mean, when I say living, I mean, I have to kick them out of the lab at night sometimes, 7 o'clock at night, and I want to go home and have my supper. And they're still working on their projects. And so it's been difficult this year. And so what we did is the students have been designing and fabricating Newtonian telescopes at home. So we furnished them with the optics. They designed the mechanical aspects, which you can see there's a version right there that was designed in Fusion 360. So they designed the mechanical aspects at home. Some cases I had students that went out and bought 3D printers so that they could print their parts at home. The rest of the students printed their mechanical parts on campus. And they did the optical designs using software at home. And then they built them at home. They built the mounts at home, and then they brought in their telescopes to do their final alignment using our optics lab. So it's really neat how we've managed to still do an awful lot of hands-on experiential learning, but at home. Same thing with my first year students. Although the first year of the program was almost entirely online this year, we sent them soldering irons and electronics kits, and they were building robots and doing some really amazing hands-on learning at home. So it's really interesting how we've managed to make that pivot. Now, a lot of people wonder, what is this photonics program that you're talking about? You know, I'm not really familiar with the word even. You know, photon sounds like something to do with light. Does it have something to do with photography? Do you take pictures? Well, yeah, we do. We take pictures, but we're not photographers. What we deal with is really anything that has anything to do with light. So the application of light, the harnessing of light, that's where we're at. And although we're a unique program within the college system, and frankly, we're a unique program in North America. There's really only a handful of institutions in North America that teach what we teach in the way that we teach it. And yet, despite that uniqueness, the technologies that we cover and the skills that our graduates come out of this program with are skills and knowledge that are needed by industries across the board. So, for example, some of the technology that we get into is fiber optics technology. Well, just think about the explosion in telecommunications and fiber optics we've had in this last year. If you go on Indeed.ca, all you see are jobs for people in the fiber optics industry, whether that's manufacturing fiber optic devices, laying the fiber, fusing the cables. I was talking to a fella that said that people are making that if you really know what you're doing, you can make $100 an hour just fusion splicing fiber optic cables together. And that's just one little tiny aspect of our program. Precision optics and manufacturing. Well, if you think about any advanced technological device, it has an optical system built into it. Look at your cell phone, right? It has camera systems. It has high-end vision technology built in it. The screen is a vision-based technology. There's so much image processing built into that. So if we're talking about physical optics or we're talking about the electronics that are driving the imaging technology, that's all photonics. And one of our largest employers, which I'm going to talk about a little bit later, they actually make all the stuff that goes into like surveillance-based technologies and cinematic camera systems and things of that nature. But then people are like, well, okay, so all right, light, optics, I get that. But what's really neat is that we also fuse and integrate mechanical technology, electronic technology. So you look at that housing of that telescope, that's all mechanical design technology. So we cover that. Electronics and photonics go hand in hand. You need electronics to communicate between the optical technologies and our traditional telecommunications and electronic devices. And of course, the thing that everybody loves about photonics is, yeah, we've got lasers. We've got big lasers, we've got small lasers. And then, but lasers are more about, we use lasers to cut things and weld things and things of that nature, of course, but we also use lasers for telecommunications. We use lasers for cinematic purposes. There's a relatively new technology that uses lasers to provide incredibly high contrast 3D cinematic experiences. And of course, the new television technologies are also based on lasers. So there's a lot that goes into this program, giving a wide range of skills that pretty much, I can't guarantee you a job, but it pretty much guarantees you a job. If we want to switch to the next slide, I just want to give you a view of what it looks like inside of our lab on campus. So this is our main lab facility, and Photonics is really set up well. Over the last 20 years, we've modified and changed how we actually approach our lab experience for students. And what we have today is a centralized location with our what we call our main flexible lab space. And then off of that, kind of like a spider's web. This is at the center, and then coming off of it are other lab facilities. And so in here, we do a lot of what we call fundamental bulk optics. So you can see each of those stations has what we call an optical breadboard, where you can set up optical assemblies. We build what are called interferometers. You set up your lasers, do a lot of really neat bulk stuff. So we build telescopes and camera lens assemblies and things of that nature. But then you'll notice that there's also an electronics test instrumentation setup on that exact same station. So because photonics is really that hybrid of optics with electronics. So you've got that going for you. And of course, there's a computer station that allows us to do all the kind of the mechanical design and things of that nature. We also have equipment in the lab that allows us to do what we call photometrics. And photometrics is all about the testing and evaluation of light sources. And of course, if you think about, 10, 15 years ago, you had one light source, really. It was the incandescent light bulb, right? That was what you had in your house. And then we had this huge push to CFL, compact fluorescence. And then almost overnight, that technology, because that was just a stopgap technology, we had LED-based lighting technologies. And whereas the incandescent bulb didn't really change for like 100 years, LED-based lights change almost daily. And so a lot of the companies that are doing R&D on LED-based lighting technologies need trained professionals that know how to do evaluations of these light sources. So for example, that big giant blue ball there is called an integrating sphere. And that's 6 feet across. So you can actually put a street light in there and test the light output of a street light and see if the color is right. You can see if the optical power is right, and all those kinds of things. And which is really important, because when you start putting up street lights on your street, you want to make sure you have enough light. And that was actually one of the biggest problems with the early street lights, is they would put up these LED-based street lights, and then it would be like super bright, and then you'd be walking into like a wall of darkness until you got to the next light, because LEDs don't behave the same way as incandescent lights and high pressure sodium. It's totally different technology. And we also do fiber optics in this space as well. And so we have a fiber optics telecommunications aspect to the program that we do in that lab. And then we also do some basic programming as well. So some basic computer programming. We do Python. We get into LabVIEW, which is used for test instrumentation. You get a really good breadth of skills. I'd like to go to the next slide. So coming off of that lab, we have what's called our thin film coating lab. And this is kind of like Nager College's crown jewel. Not that everybody realizes it, but it really is. So this particular facility is a teaching clean room. And for undergraduate use, there's maybe about 4 or 5 schools in all of North America that have a teaching clean room for undergraduate use. Now, you might wonder, what's a clean room? Is that just a room that doesn't have a lot of dust and dirt? Well, yeah. But it's more than that. So it's an environment that you go into, and you would be fully gowned up. You wear a lab coat, much like what I have here, but a little bit better than this one. You're fully masked up. You wear a hair cap. In some ways, COVID has actually been kind of interesting for photonics, because when you walk into the lab, nothing really changed for us. because we were already wearing a lot of this kind of gear. But in our case, of course, the idea is that you're protecting the materials that you're working on rather than protecting yourself. So when you're dealing with a lens, you can't have, saliva or vapor from, even perfume can actually put a film on an optical lens that could ruin an optical coating. So what we do in this space is we have this equipment here. So you can see there's a couple different systems there. These are high vacuum devices. So you load them with lenses, or you load them with substrates that could end up being mirrors. And then you coat them with thin metals. So you could, like I said, you could make a mirror. You could make an optical coating that only passes a very specific wavelength of light, or reflects a very specific wavelength of light. And that's how lasers are made, actually. The mirrors on a laser reflect one very specific color of light and pass all the rest. So we have the equipment that we can go in and we can manufacture those optical filters. We're pretty much the only place in Canada that actually teaches people how to do that. So although this is only one course area of the program, people get jobs from the program just from the expertise they get getting that training in the teaching clean room and using some of this equipment. I've had industry employers come to me and say, you know what, if the students go into that lab and actually touch that equipment, that's more experience than anyone else has ever had. And of course, you're getting a lot more than that in our lab. You're actually making optical filters. A good example of something that you're probably familiar with is the anti-reflective coating on your eyeglasses. Of course, in our case, we're not making eyeglasses. We're making lenses that would go into outer space, or being used on aircraft or in missiles or in biomedical devices. So really, really high end. And that's what we call it, precision optics, really high end optical technologies. If you'd like to go to the next slide, you can see here's just kind of a close up. This is some students loading one of the thin film chambers with some small substrates. So I believe in this case, they're actually just making mirrors. Or doing an anti-reflective coating. But really the program is, people talk about advanced manufacturing, and our program's not advanced manufacturing. Our program is about the manufacturing of advanced things that lets people do advanced manufacturing. So we're that one level up, that without us and without the kinds of technologies that we deal with, you couldn't have high-end advanced manufacturing with these robots and all that cool stuff. Because we build and we design and make the sensing technologies and things of that nature. So you can see, we also do electronics manufacturing. We teach through-hole manufacturing, surface mount electronics manufacturing, and we're teaching, at least it's been a little harder this go around this year, but normally we're teaching to the same standards that NASA uses. Because again, our graduates are building stuff that goes into outer space. You put a system in outer space, an electronic photonic system in outer space. You can't send us astronauts up there to realign it or fix a bad solder joint. So your standards of quality have to be really, really high. Can we go to the next slide? So another lab that's off of our facility is the Class 4 Laser Lab. Now the Class 4 Laser Lab is kind of neat. So lasers are classified 1 through 4, 1 being eye safe. So we use Class 1 and Class 3 lasers in the main lab that I just showed you. Class 4 lasers are a little different. So those are the ones that you really think about when you think about lasers. So, the laser that's gonna cut your arm off kind of technology, right? So we keep all of those in a very safe, contained environment behind 2 double doors with what we call a laser interlock system. We've never had an accident. I'm pleased to say in 20 years. And a lot of the graduates that come out of our program have actually gone to work for companies to become laser safety officers, to teach other people how to actually work with lasers safely. And so in this particular lab, we have a very wide range of laser technologies that are available and kind of what I call state of the industry. So we have gas-based lasers, which what you'd hear about a carbon dioxide laser. Those are really high power lasers that we use for cutting and welding. We also have what we call neodymium lasers, which is a solid state technology. So instead of having a vessel that's full of a gas that we excite, it's actually got a crystal rod. A lot of people may have heard of ruby lasers. Well, that's a solid state laser technology. And these lasers are used, again, for welding stuff, but they're also used for a lot of biotechnology things as well. So, well, a real basic version is laser tattoo removal, but it's also used for a lot of diagnostic and imaging technologies. So we'll use a laser to act almost like an ultrasound machine. But whereas an ultrasound machine detects features based on density, lasers detect it based on the color of absorption of the laser light. So you can actually see cancerous tissues, like the oxygen actually being starved from the cancerous tissue. It's really, really neat stuff. And then you can get into fiber optic based laser technologies, which if you've ever seen videos of the US Navy shooting down missiles using a laser, that's a fiber optics laser. And those are used in cutting and welding type applications as well. If we go to the next slide, this is our laser machining applications lab. So we have the lab where we have all these really cool lasers and we can do all kinds of neat things with them. But in this lab, we're actually using lasers for manufacturing. So a lot of our grads end up working for companies where they have to create the processes, because lasers all behave really weird depending on the material that you're using, the color of the material, what the material is made out of, the thickness of the material. There's all these weird things that go into how a laser is used to process another material. So we're showing students, hey, how you can use a laser to cut, weld, or laser engrave, but also how do you go about determining the processes that you're going to use to do that. If we go to the next slide. So again, photonics really gets into the whole concept of manufacturing of advanced things. So 3D printing and additive manufacturing is a huge part of our program as well. Relatively new addition, because of course the technology, the prices have come down so much. Like I said, I've got students that rather than having to come on campus, they've actually gone out and they've bought their own 3D printers to work on their projects. So for example, in the third year of the program right now, I have students that are building that Newtonian telescope I talked about. They're also building their own spectrometers. So spectrometers are a device that that we use to measure what the color is of light coming off of things. And although you might not think, like, well, who really cares? Well, lots of people care. So the food industry, when you've got, you're bringing produce through a manufacturing system, you're actually measuring the color of the food to determine the quality of the food and how ripe it is, and has it spoiled and things of that nature. In the agricultural industry, we measure the color of plants and things along those lines. I remember I worked on a project where we were actually looking at plant damage due to insects, and we were measuring that damage by using spectroscopy. So with the technology I had at the time, I could actually tell if a bug landed on that plant and walked across it, because the plant actually responds to the insect, and you can actually see the footprints long after the insect has come and gone. And you can see the damage in the plant using spectroscopy, using spectrometers. We have spectrometers on our space-borne telescopes that are allowing us to see the effects of climate change, and you can see differences in the temperatures in the ocean. And again, you can see on a more aggregated level, you can see if farmers' fields are healthy, or if they're not getting enough water and things of that nature. That's all based on spectroscopy. So my students are building them in the third year. And so again, they're the optical side, they're designing using optical CAD. And then their mechanical side, they're designing using mechanical CAD. And then they're integrating that technologies together and then writing the software that provides the interface to the user so that they can use these spectrometers. Back in April, a friend of my colleague and I, we were actually using this technology to make 3D printed masks to help out as well. Because and this is the lovely thing, is that the skills and the technology that you learn, although it's dedicated towards photonics, those skills are widely needed across industries. So you could end up, even though you graduate from photonics, you could end up working in a shop doing mechanical work or doing doing optics, or sorry, electronics, something along those lines. Can we move to the next slide? So in that vein, I want to talk a little bit about some of the careers. So in one of the big areas that our graduates get work is in the biomedical field, and that's an area where I love to see my graduates working because it's one of those areas where they're helping people. The fellow right there up at the top, he works for a company in Kitchener-Waterloo. And I know at one point he was actually in charge of going into an operating room theater with the doctor. And he was responsible for monitoring and making sure that the laser equipment, doctor uses a laser scalpel, does, puts a fiber optic cable into you to do imaging technology. You have to have a technician present there in case something goes wrong. Doctor's not going to know what to do if the laser stops working, right? He's there as a doctor, not as a technologist. And a lot of our graduates have gone to work for those companies. And again, a lot of like diagnostic type stuff, so imaging technologies. One of my grads approached me about a month ago, talking to me about a new technology that he was thinking about developing for doing imaging inside of arterial veins and imaging the inside of your heart. So some really, really cool jobs. Kitchener-Waterloo is huge for that. Defense is massive. Actually, most of our graduates actually end up working for companies that work in the defense, in the aerospace sector. So as you can see, I've got a couple image references there. Raytheon and L3Harris are probably two of our largest employers, and they make a lot of optical equipment that's used in surveillance-based technologies, surveillance-based telescopes. L3Harris builds turrets that actually have camera-based systems that are strapped on the bottoms of helicopters and F-22s. Their stuff goes into outer space, a lot of night vision type based technologies. Raytheon is kind of interesting. There's a division in Midland, which is in the middle of cottage country of all places, and they actually make high-end lenses for the cinematic industry. So, if you want to have a lens for your camera, for your Oscar award-winning camera, that's actually where you go to get it. Right here in Ontario, in Midland. They also they make the best rifle scopes in the world. People come from all over the world to use the rifle scopes that are manufactured right here in Ontario. If we switch over to the next slide, of course, you've got telecommunications. Again, that's exploding right now. The photonics program was actually started because of the telecom boom 20 years ago, and now we're right back into another telecommunications boom, putting more fiber in the ground, upgrading fiber optic telecommunications systems. Of course, people talking about 5G this, 5G that. Well, 5G doesn't work unless your towers are connected via fiber optic cables. And so fiber optics is the backbone of our telecommunications system worldwide. And so there's massive amounts of jobs out there in those particular areas. And of course, it's not just in the laying of the fiber, but it's in the creation of those fiber optic devices. And so our grads design and build those as well. And of course, who doesn't love the entertainment sector? I remember I had a graduate that called me up out of the blue saying, "Hey, Alex, I'm in California at a movie premiere, setting up our six laser-based 3D laser projector system," and it was just kind of rubbing it in me that he was at this movie premiere doing it. Yeah, we laser-based light shows, of course. You think about that, but the entertainment industry is massive for us. Just think about what you're looking at on your cell phone or in your computer or whatever it happens to be. Think about the camera systems that are used for movies. If you've ever watched Black Panther and you watch those really cool shots over the African jungle, that's actually done using technology that was designed and built right here in Ontario. So it's really, you can get into almost any industry you can think of with careers or with skills that you developed from this photonics program. And if you want to talk to me about it, I'm more than happy to talk to you for hours and hours. about how awesome it is and the career opportunities that our graduates have had over these years.
Thank you so much, Alex.
I think
That's
I'm right on time, aren't I?
you are right on time.
Okay.
Perfect. Very precision. That was great
We're,
precision on
we're
that.
all about precision.
That's right. So thank you so much. And you know, I'm leaving this information, your contact information up on screen for a minute here because you know, I think that's so amazing how you do. And I know that you do speak to anyone who's interested or has questions or wondering about the photonics program. You're happy to connect with them. And we really appreciate that. And that's definitely a hallmark of Niagara College. I find that our instructors and professors across the college are so accessible. And if you're considering Niagara College, that's what you get. You get such passionate and accessible instructors who are willing to connect with you all the time,
And
as
it doesn't
Alex.
and it doesn't end at graduation because, like I said, I have graduates from 20 years ago that reach out to me and talk to me. And you know, I talk about, you know, when you started orientation, photonics is a family. And because it's such a small program, once you get out into industry, you're all working together. The people that you went to school with, you're going to spend the rest of your life with. And so it really is a really great family dynamic that we have out there.
Yeah, that's really cool. Really cool. So I'm just going to have one more closing slide, and then we'll have some more discussion. I just want to again remind those of you who are watching that if you do have an offer of admission, please accept your offer by the deadline of May 1st. You don't want to miss out, especially on this fascinating, unique program. And for the rest of the event, drop into one of our student services Ask Me Anything sessions. They are open until 3 o'clock. And you can speak live to a staff member. As I said, it could be someone from financial aid or admissions or the student administrative council, our Indigenous department. All of those areas are open until 3 o'clock for sessions and questions. Recordings of all sessions will be available online after the event. And so this session, you could go back and view it. You will be able to access it, as well as if there was another session that you had hoped to see, but you couldn't pop into it because of scheduling, you'll be able to look at the recording. So now we will be open for any further questions. So again, if you have any questions, please put them into the Q&A box. I know I have a couple of questions because I just found that the presentation, every time I have, you know, obviously been a part of the photonics sessions before, and every time I just find it so interesting. And in particular, it's just amazing to me the broad range of career options. It really seems that there's no sector that you can think of that doesn't incorporate something to do with our photonics program or lasers, because you mentioned everything from medical to manufacturing to entertainment. It's amazing the range of careers.
And in heavy industry as well, because I mean, you walk into any heavy industry plant, and they're going to have laser cutters, they're going to have laser welders. And you know, I was talking to a fellow that one of the largest plants in the world that does laser welding is again right here in Ontario. It's amazing how much there is right in our own backyard. But he, you know, he talks about how difficult it is to get qualified people because it's it's very difficult for any other school to set up a program like this. We were very, very lucky here at Niagara College 20 years ago that we had a microelectronics facility. And so when we started this program, we leveraged off of that and grew the program out of it. And that's what gave us the clean room capability. But you know, you think about any piece of engineering technology that you get exposed to, it could be as simple as the light bulb in your house, right? It's optical, it's electro-optical, it's you know it's us. And you know, you know, depending on the age of the people watching this, but there used to be this commercial, you know, the BASF of you know, of the world. And it's, you know, this underpinning technology that everything else relies on. If you want to have an autonomous car, you can't have an autonomous car without cameras, lidar, you know, the artificial. I mean, I haven't talked about artificial intelligence, but yeah, we don't do a lot of artificial intelligence within the program, but everything that we've done projects with artificial intelligence because it's all based on image processing. And so without those technologies, you can't do the modern world. It's just not it's just not possible. It's something as simple as, like I said, staring at the screen right now. That's either an LED or a laser-based display technology. If you want to get your old school, CRT television, it's still photonic. If it's generating photons, it's us. Uh, you want to use the internet, can't do it without fiber optic technology. If you want to find out what the weather is, sorry, that's still us. It's you can list any field that you want, and they need optical or photonic based technologies. And the nice thing is we're not just that because we consider ourselves a niche program, but we're not just photons. We're the mechanical systems that hold everything together, and we're the electronic systems that allow you to do the interfacing. So it's a really, really wild program that you
Yeah.
won't find anywhere else.
Yeah, it's amazing. It's amazing. Now, Alex, one of the questions that that we sometimes get in the recruitment department, and I know that, and obviously with your 20 years of experience with the program, what would you consider would be the profile of an applicant? What do you think is a successful student, right? Because some people might be thinking, looking at this presentation, oh my God, I don't know if I could do that.
Yeah.
Like it looks pretty technical
A
and
lot of
pretty.
people get scared. I'll be
Yeah,
honest.
yeah, it
They
can
do.
be. So tell us about who could be a successful applicant.
If you like working with your hands, and you like maybe the concept of physics sounds interesting, but you want to do something. Applied physics. That's what we're at. Applied physics is not the same as physics. Applied physics, well, I'm going to upset somebody, but it's fun, right? It's very fun, and of course my third years are really loving it right now because we're building these products. And a lot of our graduates are ones that, or sorry, a lot of our students are ones that have been in like the robotics club, the robotics club in high school. We've had, again, real builders, people that, took shop in school, things of that nature. Now there is math. I'm not going to lie to you. It's still physics. But you have to remember that we're not assuming that you know anything coming into this program. We're going to give you the foundation to build your knowledge and build you up so that you're not starting right away dealing with the really, really complicated stuff. You're taking two resistors and soldering it together, right? You're turning on that light bulb. You're, learning some real basic trigonometry. We assume you know nothing, and then as long as you're interested in the work, right? You like to get your hands a little bit dirty. You're going to have fun with this program. And I've had graduates of university come back to take the 2-year program just to get those cool skills that then allow them to get a job. It's really remarkable. And then I have folks coming straight out of high school. I have mature students coming to take this program. There's really no one profile of person that I would point to and say, hey, that's a photonics person. The key is that you might be a little introverted, and so that you can dive into it, because you can really get lost in some of the technology. Some of the stuff my third years are doing right now will just blow your mind, well beyond anything that they could have thought of, they could have done when they started this program.
And that's I imagine that we have that experience, 20 years of experience of bringing people along, right?
Exactly.
And yeah, if they come in with no knowledge, that's okay. We can take you along, and you will get to that point, where you are building these 3D models and working on things that could be used in space. Like,
Yeah.
yeah.
And because the beautiful thing is the technology has evolved so much over the last 20 years as well that, I couldn't imagine of doing some of the imaging system stuff that I do now with my students. It wouldn't have been possible. The algorithms and that were so advanced, but the technology's come along so far that you can do amazing things without having to go, that extra, layer down. So what we really do is we teach you how to take existing technologies and integrate them together to do amazing things. So you don't have to understand, the quantum uncertainty principle. It's cool, but you don't need to know that. But you can still build a laser, right? You can still integrate that laser into a system and communicate, from building to building. you can still build a telescope and point it at the moon and look at the craters. It's really remarkable what you can do
Amazing,
just with a little bit of
amazing.
guidance.
Yeah, that's amazing. And so why would someone choose this program versus, going to university for physics? Because often, if I'm really good at physics and I'm taking U-level physics in school, I think, well, I should go to university. But why might I want to consider this program instead of going to university physics?
Well, in some regards, it's almost a false choice because I've had students both go at it both ways. I had a student that graduated from this program and was actually working in the lab that Donna Strickland works in at the University of Waterloo. If you don't know who Donna Strickland is, she won the Nobel Prize in physics, and you know so I've got students going at it from that direction because they want to learn more about the theory. And then I have students that, are in university, they go through applied physics and they're like, geez, I've got a lot of theory, I got a lot of knowledge, but I don't have a lot of practical skill. And what typically will get you a job in a lot of these companies is that practical skill, because our graduates, they come out of the program and they just hit the ground running. They know how to use the equipment, they know how to build the stuff. They just need to get a little bit of training in the specifics of that particular company. So if you want to, after 2 years or 3 years, have the skills that you need to get that job, this is the program that will do it for you. That doesn't mean that university is closed to you after the fact. I've got students that have gone on to do engineering degrees. I've got students that are doing applied physics. But again, the skills that get you the job, that get you, get the interview to get the job, that's the kind of stuff that we're teaching you.
Yeah, so those jobs that you showed in your slides, whether it's medical or entertainment, manufacturing, you're saying that they see this credential, and especially I imagine Niagara College has a name for itself because
Oh,
this
very
is
much
a
so,
very
because we're
unique
the only
program.
one.
Yeah, we're the only one.
I,
So if they see Niagara College and this credential, then they are getting that interview or they are getting that job.
yeah,
You don't have to have a University of Waterloo
no,
or something like that.
I'll give you a perfect example. So we had a company that, like I said, it was based in Midland. Do you know how many colleges and universities you have to pass by to get to Niagara College, right? And they came straight to us because we were the only school that could provide them with the skills that they needed for the workforce they were looking for. So they went by all those universities, all those colleges, drove the 4 hour, well, it's not 4 hours, whatever, it's a long drive. They drove all the way down here to Niagara College to come see us and say, can you help us and get more people? And so that's what this program is all about.
Yeah, getting, having those skills, right, to
Yeah,
get
to
that
get
job.
those jobs.
And so talking about the skills and that's so interesting that this is really a hands-on program, even though it's something, that the word photonics and lasers, but it's hands-on. And you've been describing a little bit about how teaching has been happening over this last year during the COVID pandemic. And so it sounds like there's been, we have been able to adapt. And so, looking forward to the fall, and we don't know what the conditions will be, what public health will be telling us, but it sounds like we've been able to adapt and we're ready, and that students will still get that hands-on learning, even
Uh,
if
yeah.
the pandemic conditions are continuing in some way.
No, absolutely. I mean, of course, our hope is that we're only going to increase the on-campus lab component, but we've learned so much over this last year. I have to say, a lot of people's like, how the heck can photonics do remote learning? And so, well, let me tell you, it wasn't easy, but we came up with some really great activities. We actually worked with some of our partners down in the United States because they have some amazing funding opportunities down there. So they actually donated some optical kits, and we send out optical kits to every single person in the program in the first year of the program, so that they could get their hands on some lenses and some lasers and build up some optical assemblies. And like I said, we've been building product at home. You'd wonder how you could do that, but yeah, it's possible, it's doable. And those kinds of innovative tendencies and the ability to think outside the box and do this kind of work is exactly the kind of innovation skill sets that these companies are looking for. They don't want somebody to just sit there on an assembly line and glue things together. They want people that can really think and innovate, and that's an important part of what we do.
Yeah, you're right. And innovation is really a cornerstone at Niagara College across so many of our programs. If you go on our website, you'll see a lot of the word first. The first, and in this case, the only photonics program in the province, right? And the first teaching brewery, the first teaching winery, all of the programs, all at first. Innovation is a major component of the Niagara College culture, and it shows in this program.
Applied research right here at Niagara College was a provincial first, and the first program in that first thing was photonics.
Yeah.
So
no,
we are a very innovative group, and we will bend over backwards to help you in any way we can, because we want you to be successful. And like I said, it's a family dynamic. So you're going to be working. You'll be 20. Well, I don't know, maybe 20 years from now. I hope I'm retired, but it's a family dynamic, and so we're here to support each other.
Yeah, you're absolutely right. And so we just have a couple of minutes left, but I know a big question, and I think it's an important one that people often ask when they're considering going to post-secondary: will I get a job? What are employment prospects like for someone with a photonics?
Go on Indeed.ca and type in optics, and that will answer your question. Don't look up photonics. It's not necessarily the best name for the program, but because photonics is usually in the industry, sometimes it's this very niche thing. But in terms of the skills that we give you, look up optics, look up thin film, look up vacuum, and fiber optics. Oh my goodness, the jobs in fiber optics right now is unreal. And I had one company that had one area of their program, 15 jobs at one company, that they said we need to fill 15 spots. I don't have 15 grads. That's one company, one area of one company. It's so the jobs out there are just, it's mind-boggling. I have to say right now.
Yeah, good to hear. I mean, obviously it's an industry that still thrives, pandemic or not. It's a program that's still thriving, and our teaching and learning is still thriving throughout the pandemic as well. So thank you, and huge hats off to you, Alex, and your dedication to the program and the quality of the education that you're providing our students. So encourage all of you who are watching, if you're considering this program, it would not be a mistake. It's a great program, and will absolutely give you the skills you need to work in a fascinating and evolving field. So thank you again, Alex. I'm going to close off the session. I don't see any further questions. Thank you so much for this great presentation, and thank you so much, Lauren. And I hope everyone has a good day, and encourage you to visit the rest of our sessions that are happening throughout the day. Go to the Open House website at niagaracollege.ca/open house. Thanks, everyone.
Bye.
Bye, everyone. Take care.